You see, I get pulled out of my room 500 times a day. Yeah. Yes, take a pass.
Oh, yeah, that is right. I canceled earlier, I didn't cancel last time.
Yes.
I was so confused, I was like, why?
All right, number 9.
Hold on.
If I can find my pen.
See, these NDXs are gonna mess me up, but I keep trying to put them in the error.
And so that cancels out one.
All right, number 9. Are you using the quotient rule?
Yes. For partial.
And no wonder it's hard. Okay.
So there's -1 and then
Please take advantage of the fact that this sucker is a logarithm. That's why I picked it.
I don't think I took advantage of that, because that was a lot of
Okay.
work.
Yeah. Okay. Do you remember when we talked about it yesterday, very briefly, that the log of a fraction is a subtraction?
Oh yeah, I forgot about that.
I just wanted to write loggy on the board. All right. So, rewrite this thing.
Well, that makes much more sense than what I was trying to do.
Yeah, I forgot about that, but it's okay. I still got the right answer.
Right? Now, you cannot, in this second one, distribute the natural log. That's against the rules. Don't do that. However, in the first one, these two cancel each other out.
Wait.
Can you just bring the X?
This is
down
a different.
first?
Yo, what is she?
She's doing the log of X minus log of Y, which is equivalent to what we did, but shorter.
It's the rule of law.
That's
easy.
Yeah, that's the formula, which if this is a logarithm, that problem sucks.
Yes, it does.
This problem, yay. Because of this piece right here. This piece says, hey, if I've got to subtract a fraction, I can break it up into 2 pieces with a subtraction.
Oh,
Okay?
okay.
Now, so I did log at the top minus log at the bottom. Natural log and e cancel each other out. So this really becomes this. Haven't taken a derivative yet. I've just rewritten it for a much, much easier derivative. So, derivative of x is 1 minus the derivative of natural log of something is u prime over u. So the derivative of e to the x minus 1 is e to the x, so that's u prime over u. And did they leave it like that, or did they get a common denominator?
Look at 1 over
Yeah, something's.
Okay, so common denominator, you can multiply your denominators together and then cross multiply. So 1 times this thing minus 1 times that thing.
Okay, and
and
we're
then
back.
they cancel.
And we're good. Yeah.
There's
Yay, logarithms.
We did the hard way, but we still got the right thing.
That's okay. You can get there that way too. Nothing wrong with the scenic route. You got time.
Can you explain how you did that bottom step again?
From here to here,
No, the one before.
Here?
That one to that one.
from here to here.
Yes.
Okay. The derivative of x is 1 minus the derivative of the natural log of something is u prime over u. So u prime, the derivative of e to the x minus 1 is e to the x over that thing, which is e to the x minus 1. Okay?
Will you use practice questions?
I will. And I have also already posted an old test today.
How do you get it?
How do I get what?
How do you get that?
Which that?
The bottom part.
Here?
Yeah,
From here to here?
yeah,
What's the derivative of x?
1,
1 minus the derivative of natural log is u prime over u.
right.
So the derivative of this is e to the x
Right,
over this thing.
and then like, how do you get to where it's
Then we got a common denominator by multiplying the 2 denominators together. 1 times e to the x minus 1 is e to the x minus 1. And then you can cross multiply
why?
because you're trying to make it match there, so you need a common denominator. You could have left it for me right here. But if you get your denominator, your common denominator, by multiplying the 2 denominators together, you can cross multiply. So, 1 times e to the x minus 1 is e to the x minus 1. Multiply these two things, so 1 times e to the x minus 1 is e to the x minus 1, minus these two things multiplied. Okay? Good?
Um,
Yes.
I'm sorry.
That's
If there's something that I missed, it's like, why did the natural log and the e to the x cancel? I just missed something.
Okay. Natural log is a log base e,
Okay.
so their bases are the same.
Okay.
If their bases are the same, they cancel each other out. It's like a square and a square root.
Okay. I never had like a whole unit.
Wait, but the x has to stay.
The x has to stay.
I lost the negative.
It's just like whatever's underneath the square root stays. It's just the square root and the square that cancel each other out.
Oh,
Okay? Number 10, we ready?
We haven't done it.
I know. We're going to do it together. Alright, number 10, we've got y equals the inverse tan. Oh, it's doing its monkey writing thing again today. Yay. Of x over 2. Seriously? Did you see that?
It's beautiful.
No, it makes me angry.
After you're finished, we go back, cause I thought I got it done, didn't.
Yeah.
It's too early.
Or can.
Alright, where you at?
How'd that cancel out? The top part?
This and this?
Yeah.
I got an e to the x minus e to the x.
I had to.
I thought you were mega
Oh, okay.
because like I'm so scared.
That's okay.
You good?
Got it.
Alright, so for our inverse trig functions, remember come over here on the side and figure out what u prime, and u squared are. So what is u?
You
That's a terrible sentence if not in context, right? What is u?
X over 2.
I as a student.
X over 2. It might be helpful to think of that as 1/2 x when we're taking the derivative. Okay? So get used to kind of thinking, those two are the same thing, right?
The first one.
Yeah,
Huh?
it's like the first step. That goes to
We need to take the derivative of that for number 1 and bonus.
Okay? So, u prime, I'm going to look at it like that, because that's an easy derivative, right? What's the derivative of 1/2 x? 1/2. U squared, I'm probably going to look at it right here and square each piece.
Wait, when would you use? You have to use it now.
In the formula. Because our formula for arctan is u prime over 1 plus u squared.
I forgot that was what that was. I
Yeah.
was thinking we were using like the normal tangent. I was like, why do we even need huge?
No, why do we, because you see that pesky -1. It's terribly unfortunate notation, but that's what they chose.
Then okay though.
Alright, so we plug it in. Our derivative is u prime, which is 1/2, over 1 plus u squared. And I'm certain we're not going to be fortunate enough for that form of the answer to be on there. Okay, so strategy that works most of the time. Your denominators are 2, 1, and 4. So what's the common denominator? 4. Multiply everything by 4. That usually takes care of it.
Oh, okay. Wait, why is there another 4? Wait, never mind.
You good?
Yeah.
Okay.
Wait,
Question?
I'm just. I missed this day and I never finished the video. So
Oh,
I'm just
that makes it challenging.
It's processing.
Your question?
What's happening with all the U's to the side? 'Cause I'm very confused.
Over here on the right?
Yeah.
Okay.
I don't know what just happened there.
Anytime I've got an inverse trig function, I go over there on the side because I know all of my formulas use u, u prime, and u squared. So I go ahead and do that scrap work on the side and write my formula down. Okay? Every inverse trig function has a u prime, and a u squared.
What's happening with the U squared?
It's just.
I squared both
Squared
pieces.
X over 2.
Oh.
Okay?
I was like thinking you were squaring 1/2.
No, no. Okay.
I got you.
Okay? Alright. You ready for me to keep going?
Yes. Yes.
These two will cancel to give a 2, right? RJ, you got a question on your face. What is it?
Yeah. Where's the 4? Is that 4 from the bottom? Where's it for?
I looked at all the denominators and said, I got a 2, a 1, and a 4. What's your common denominator? 4. And you multiply every piece by the common denominator.
That's how.
Okay? So, when we clean all that madness up, we end up with 2 over 4 plus x squared. Is that what their answer looks like?
Yes.
Yes.
Are you okay, Kylie? You have to copy on
I'm gonna
that.
have to fly by myself to not simplify that to 1/2.
Please, yeah.
I understand.
Get a little rubber band, and when you catch yourself trying to do it, just snap it.
Why can't you simplify one?
Because it's 2 over a fraction.
Because look at it like this. If you had 2, let me make that bigger. Like 2 over 4 plus 5. We know that that's 2/9, right?
Yeah.
If we were to cancel it,
It would be 1.
it would be 1/7. And we know that that's not true. So if I'm in doubt about whether I'm allowed to do something or not, I come over and do it with little bitty numbers to see if it was true.
Okay.
Okay?
That's not mine.
All right. Anybody need more time with that one?
How he does.
Okay, take your time.
Go back to the same that's fine.
Did you already?
That's a lot.
Never mind
You good?
that. Yeah.
Okay?
And let's just move inverse.
Yes.
I know you literally just answered this, but
That's okay.
A lot of times you'll see
Like
those
the
like
2 and the 4 cancel.
Okay. Because I come over here and if I'm not sure, I try it with numbers. I know that 2 over 4 plus 5 is 2/9. If I try to cancel those, I get 1/7. And I know that that's not right because I know the answer has to be 2/9. Okay? So if I'm not sure, I pick numbers. I come over to the side and try it. If it worked out, it's probably okay to
Would that be
do.
an answer for you?
Huh?
The one without the common denominator and stuff, or no? Where it's half over
This,
1 plus, yeah.
I mean, like on free response, it'd probably be correct. They couldn't penalize you for that on the AP exam. I don't ever see these represented as free response. They're always multiple choice, and they almost always do this.
So they go.
Yeah, they don't like a fraction. They do like a fraction.
So why does it have a 4 with it? Why do you need to have a, if it's already a 4 denominator? Like where you do 4 times?
Okay, you got why I chose 4.
Yes.
Okay, when I multiplied this piece by 4, I got left with 2.
Right.
When I multiplied this piece by 4, it's 4.
Right.
When I multiplied this piece by 4, the 4 is canceled and left the x squared.
Why do you have to multiply the 4?
Everything gets multiplied by 4.
Okay.
It's like putting a gigantic 4 on the outside.
Yeah, it's like doing this, and then you have to distribute the 4. So it's just easier to put it next to each piece. I learned a long time ago if I only put 1 4 out here with the parentheses, people only use it once. But if I put it on each piece, they remember to put it on every piece. Yes.
So it's like multiplying by 1, but in the fancy way.
Yes.
It's just 4 over 4.
Exactly.
You-
I like it the fancy way. All right, ready for 11? Going once, going twice. So,
That makes sense.
okay, I'm not looking at the answers. Is the answer either D or E?
For what?
Number 11?
Oh, 11, it's A.
A, okay. D and E are bait answers, okay, because they're looking at U prime over U, and you see that over U, and you see that denominator. So when I see those, I'm thinking, we may be headed to those. But if it's not the right answer, then we'll see why here in just a second as we get started. My guess is there's some creative trig simplifying going on here.
Wait, it's A, right?
I don't know, I don't have, is it A?
Yeah, it is. Oh, yeah, I got it right.
Alright, so this is the natural log of something. So if I want to take its derivative, I'm going to do U prime over U, right? I'm going to go ahead and deal with the over U so that I can focus on the U prime. So far, so good. Alright, so U prime. What's the derivative of secant? Secant tangent. That's a secant. I'm not gonna go back and erase it because of the delay. It's just driving me crazy. Okay? Plus, what's the derivative of tangent? Secant squared. Okay, so that answer is not on there, but notice this. So if that answer was on there, box it up, you're done. It's not there, so we're going to have to do something else. So let's factor that thing out. Remember, factor for a purpose. If I take secant out of this one, I'm left with tangent, right? Plus, if I take secant out of this one, I'm still left with one of the secants, right?
Me too.
I'm going to go ahead and stick that thing in parentheses because don't these two match up? So can't you cancel them out? Because they're multiplied. That's why. So you're left with secant.
Okay.
Okay? Huh?
It's math learner.
Yeah, there you go.
Anyway,
That's
So
the way you wanna
just
look at
print
it,
up
Gabby?
top.
Alright, yeah. Alright, were there any questions from the book? Going once, going twice. So, alright, logarithmic differentiation. Not a formula, it's a technique.
Is this the cheap way to do it?
It's not a cheat way, but it's
The quicker way?
an awesome way.
Oh, that's not good.
What even is a logarithm? Like I know what they are, but like, why does someone need them?
I don't know why they originally invented them. I know for the longest time they used like when I first started, like there were books and which pages and pages and pages of logarithmic tables, logarithm decimal approximations. I think it was to get more exact approximations for stuff. I'm not exactly sure. It was before they had like a lot of calculators to do it. So if you wanted to be super accurate and you couldn't get it like on a calculator, you could express it in terms of logs, and they made these tables, and I know they do like the Richter scale is measured in logarithms, and
Okay, because like everything else has to be like the differentiation or whatever. And then there's just logarithms.
Yeah.
Like,
and they end up being a handy tool for harder problems, which is nice. I don't think that was their original intention. It's just a nice side effect. Okay, it's like if
I have used one of those tables.
they make your eyes twitch, don't they? Okay. It's like awful. So anyway, so they can be a miserable thing, but they can also be a lifesaver. Well, not a literal lifesaver, but you know.
you never know.
You never know. Okay, we ready? Which one of these two things do you think would be easier to take the derivative of?
You're gonna go with B because it's uglier.
I'm going to go with B because it's uglier.
Yeah, it's like a trick question.
I don't know. If I was taking the derivative of A, let's see what we'd have.
What else would we
We'd have a quotient rule, 2 product rules, and 4 chain rules.
So let's go with B.
is subtraction.
If we went with B, we take the derivative of this little bitty piece, the derivative of this little bitty piece, the derivative of this little bitty piece, and the derivative of this little bitty piece. Wouldn't it be great? Much better than that, because I'm going to screw that up. I've been doing this for a long, long time, and I'm going to mess that up. Okay? So if it was a logarithm problem, if there was an ln sitting out front of that sucker, that'd be great, because then we could do this. Okay? If there was not, then we're stuck here.
It's technically the same. It's the same problem. You've just rewritten.
Well, it would be the same problem if I had
Yeah.
that. Those two are equivalent.
Yeah.
So wouldn't it be great if that thing had that?
Mm-hmm.
It would be awesome. That's the basis for today's lesson. We ready? No one.
That's
That's what we
That's
get.
it, just blop a
So,
log.
now,
Oh, what?
we're back to this thing. Take a minute and write it down.
Oh,
Yeah, honey, I was like,
okay.
If we have to.
no bueno.
Is it or is it like 2?
This is x minus 8 to the 5th, and then times the cube root. They kind of blend in together. The math software will not allow you to put in spaces.
Before I forget.
If I want a space, I have to trick it by putting in a multiplication dot. A really tiny one that you can't actually see, so I know. So, in its current state, I think we would all agree that this problem should be taken out and shot.
Okay. That was
We all agree?
Yeah.
Yeah.
Okay.
Really wish it was a what?
Logarithm.
Logarithm. So we gotta figure out how to make that happen.
Put it on
Remember? You're not wrong. Remember back in, I don't know what class it's in now, when you were like solving an equation and you need to get rid of a square root, what'd you do?
Take the square root.
You square.
Oh, yeah.
But could you just square one side?
No.
No, anything you do to one side, you gotta do the other?
there.
Oh, we really want the right-hand side to be a logarithm, but it's a package deal. So if we make a logarithm on the right, what do we gotta do to the left?
So,
I like that problem better.
We did.
We took the log of both sides.
Okay.
And we're gonna go with natural log because its derivative is shorter. U prime over u instead of u prime over u, natural log of the base. You can use whichever logarithm you want. We're going with this one. It's the same as taking the square root of both sides or squaring both sides or adding 5 to both sides. We're taking the natural log of both sides.
It upsets me that it's that easy.
What do you do with it after? After, we say, hey, we're very excited now that this problem is a logarithm problem because we can then rewrite it.
yeah. Well, like after you.
Okay. Pieces in the top are plus, pieces in the bottom are minus, right? Okay. Exponents come down front. So this is going to be 3. And there's no way I'm going to get this all in the same line. Let's try this down here. I'm going to start over down here. So this piece is going to be 3 natural log of 2x plus 1 plus, what's the exponent on this thing? 1/2, bring it down front. 1/2 natural log x squared minus 4. Denominator gets a minus, right? Minus, what's going to happen to the 5? 5 natural log of x minus 8. Minus, because it's in the denominator. Cube root is what exponent? 1/3, which comes down in front. Hold on, I'll backtrack and get you. Really?
So,
Hi, Gabby, you have a question on your face. What is it?
Between the 5 natural log of x minus 8, why is there a negative there now?
Because it's in the denominator.
yeah.
Numerator pieces get pluses. Denominator pieces get minuses.
Oh, okay. I didn't know that. So numerators get pluses. Okay.
Denominators get minuses. Now, easy. Now it's just like, you got 4 problems, just do them one at a time. I'd rather do 4 little problems than one ginormous problem, right? Okay. Take the derivative of everything, right? What's the derivative of natural log of something?
Derivative of itself over
The derivative of that thing over that thing, right? So far, so good? You gave me a funny face. the derivative of that thing over that thing.
No, I get it, I'm
Okay.
just wondering where this is gonna end.
It's going to end. The great thing about these is they hardly ever simplify their answers.
You have to multiply everything. It's awesome.
Okay. All right. Constant multiple rule, 3 tags along. U prime over U. Travel to the next piece. Plus, constant multiple rule, 1/2 tags along. U prime over U. Travel to the next piece. -5 tags along. U prime over U. Minus. Travel to the next piece. 1/3 tags along. U prime over U. So far, so good?
Did you distribute the negative?
Did I distribute the negative earlier? I'm not sure what you're saying.
Oh, no.
Please resist the urge to cancel those 2's. I'm going to get everyone a rubber band for Christmas, which is inscribed if you can do that with rubber bands. Would snap me if you try to cancel. All right. Here you can. Do you see the difference between those 2 pieces? This 2 is like permanently stuck with that x plus 1. This one is out separate and it's just an x. Okay?
Why is it 2 negatives? Like, why is it?
Denominator pieces always have minuses.
Like, all of them?
For the logarithm, denominator pieces always have
I'm
minuses.
not questioning, I'm just stretching.
Even
You're praising the Lord because you love logarithms. Yes.
Okay. It's stupid. But
No,
the
it's
whole
not.
like cancellation thing he's messing with me. Like because the 2x is still a 2x.
Okay. Because this is like 1/2 of 2x, right? This 2x is it's like a 2x plus 1. That's one piece. You can put it in parentheses if you wanted to.
It's like, as if
Okay.
it's not
part of it.
Right. You can't go in and take anything with a plus or minus technically has parentheses around it. And you can't go in and take part of a parentheses away.
Okay.
Okay? That thing, you couldn't go in and take it. This one, it's a multiplication. You can do that.
Okay.
Better? We'll get there. We'll get there.
Okay, another quick question.
Yeah.
Same thing. Like, even if it's negative, like the exponent is negative 2.
Yeah.
Like, because the x, it's log, like the first log minus the second log.
Mm-hmm.
Would it be, even if the exponents are negative, wouldn't it be
You
negative?
you could theoretically think about like everything was positive and that's a negative. That's a 1/3 exponent. When you bring it down, turns into the negative 1/3. I mean that's
Yeah,
that's
but-
another
but
reason why
wouldn't
that
it
would
be
be
a
negative.
positive?
No, you can only use that
Because-
negative concept once.
No, I meant because it's a negative.
Alright.
It's a negative.
Let's do it this way.
value.
If I took this whole thing and changed the stuff in the denominator up here, let's say I did this. Okay, it's in the top, so it would get a plus, but when that -5 came down front, it becomes a minus.
Oh, so it's not.
You're trying to use that minus twice. You're trying to use a minus because you brought it up in the top and a minus because it's in the denominator. But when you bring it up to the top, it's not in the denominator.
Okay.
Better?
Okay. So that's why that minus is there.
Yes.
That makes sense.
Okay. So far, so good. All right. Now, remember, our goal here is to find the derivative. I've got this divided by y I'm going to have to deal with. Right? Okay? Which is going to be way easier than you think it is. Trust me. Okay? So, I'm going to multiply both sides by y. We okay with that? That's gone. Good?
Whoa.
I multiplied both sides by y. Took that y, threw it over there. because I want to get the derivative by itself. Our goal here is to find the derivative. Y prime is the derivative.
Gotcha.
Got You got a question on your face. What is it? Okay. You okay that our goal is to find the derivative and that y prime is the derivative? Okay. Y is dividing it, so to get rid of it I have to multiply. Okay, so we're good now. Okay, so put that away. We'll start taking phones away. Okay. So let's clean this up. This is going to be a 6 over 2x plus 1. Okay. Plus x over x squared minus 4. Minus 5 over x minus 8. Minus 1 over 3. Put that x plus 5 in parentheses. So far so good. I haven't dealt with the y yet. All I did was really multiply numerators. Wasn't y the original problem? Didn't it say y equals this ugly thing? Y is the original ugly problem.
Like before we needed one more. That right there. Oh. The 2x. No, that one. Well, that's okay. I was like, I don't have room for that.
Done. The end.
Is that it?
That's it.
Really?
They leave it like that.
God bless America.
Better yet, God bless what?
Logarithms. I'm so happy.
I'm so upset with
If they ever make us distribute
This
that
actually
out,
kind
I
of
will
bothers
cry.
me because it looks.
I mean, we could do it.
It
No.
looks old, but that's
No.
okay. My house looks like it's not finished all the time, but I still love it. My car sounds like it's not finished all the time. It rattles and shakes. My friend drove us to Atlanta in my car one time. She goes, I hate driving my car. Your husband should be shot. I said, no, I love my car. Just because it rattles and shakes, you can't take it out and shoot it. I rattle and shake. Nobody takes me out. And then I made her apologize to my car.
Nobody takes me.
Her name is Sky. She deserves some respect. She's very good at a long life.
Respect you.
Why you can't give coffee back though?
Carrie. No, it wasn't Carrie. Christine was the caller that came to life. It was a Stephen King movie.
Yeah, I watched that.
Yeah. All right. We ready? Oh, Heavenly Day. Looky there.
Let's do it.
Oh.
Let's do that one. I had a blank slide in there.
They thought it was just
I must have dozed off on one of the hurricane days. So, blank slide. So in its current form, we would have the product rule like 2 or 3 times and 3 chain rules. And if you want to do that, feel free. Tell me what you got. I'm not doing it that way.
How would you do product rule with 3?
There's a bonus question right there.
Oh.
Isn't it? Don't because it's multiplication. Don't you just take it piece by piece, like you do 2 together, and then you take that one product and.
I actually
I'm
did
so
that on a
sorry.
test. I think on one of the old tests I've already posted, that was a bonus question.
And
With
do we
F,
have to
G,
use
and H.
the
So we like-
product rule?
No, I don't want to. If you want to, go. Just tell me
It
what you got. I'm not
be almost like different.
No, I'm
from
not doing it. I love it.
I mean, not exactly, but like the same kind of idea.
Because technically you take 2 pieces to be 1. Like you group it like F and then GH is 1. So first times derivative of the second, you gotta use the product rule on that one.
Oh,
But, yeah.
okay.
It'd be like 2 times 2
And then you
times
have to
2
distribute.
is 4 times 2.
Yeah. So anyway, I really wish that was a what? Logarithms. And if I got to choose between any of the logarithms in the world, which one do I like the best?
Log of 2.
And that, no, you do a log 4 if you want to.
I bet
Natural
you
law.
like natural law.
Technically, you could do any log you want. Every problem I have ever seen in calculus, they use the natural log, just because it's an easier derivative. Okay? what that allows us to do is to break it up and take little bitty derivatives.
There's too many
Baby
parentheses.
derivatives. We raise them up when they're little pups and
Yeah,
grow
we
up to
never
be
raise
big
them
derivatives.
We just don't say babies.
Okay. All right. So they're all in the numerator, so they're all going to be what's? Positives. And what am I going to do with their exponents? Bring them down front. So 3 natural log 2x plus 1.
No, so we're not married.
No?
No,
Not yet?
you're good.
Okay.
I'm goofing.
Wait,
Seven.
Wait, even though those are multiplied, you can just like put a plus sign in between?
Because
Oh, because the natural logs, the multiplication is addition.
Division is subtraction.
doesn't matter how many pieces you got.
Yeah.
Nice, right? Product is a plus, they start with a P, and fractions are subtractions.
Gotcha.
They run. Alright. Okay. Plus, oh, that'll bother me. This is probably when I first teach logarithms and advanced algebra. This is the day I have in my head, like when I'm teaching them. Why do they get there? They don't like this. They don't like it today. They like it. All right. So haven't taken a derivative yet, but the derivatives are easy, right? We're just gonna u prime over u our way down the road, right? I don't even know why I bother to change colors. Half the time it does and half the time it doesn't. So far so good? 3 just tags along. U prime over u.
Oh, okay. I was wondering why you put the prime on top and on bottom, and it's, yeah.
7 tags along. U prime over u. 4 tags along. U prime over u. I was supposed to send Ariel a quiz. Write myself a note real quick as I stand directly in front of you and make your life difficult.
No, honey. It is. Due to the actions and angles, I expect the
Said it right back.
Because they have the motion sensor ones, and I'm there so often. I'm just like,
All right. So far, so good?
So like I sit up and I wait, and I just have an
Can I cancel those 2's?
No.
No. Huh?
Sorry.
Just because. Okay. All right. My goal is to get the derivative by itself. The good news is the same exact thing happens here every single time. I got to multiply by this denominator, right? Okay. So
Can we not distribute like the constants?
I'm going to do that.
Okay.
You gotta be on the mouse. You're on the mouse. You're on the pen.
Yeah, but
Oh,
Oh yeah, it was
wait.
it was
Never mind, sorry.
it was
Why is
rebooting
that
itself.
Why
Yeah,
is that
it
working
likes to
when
keep
it's
me on
not
my
Yeah,
toes.
it's not, I'm really confused.
It's done that like the whole time where you're like, oh, you're writing,
Hence
but it
not
doesn't
selected.
say.
Yeah, I don't know. It's got a mind of its own. But like my car, I'm not going to take it out and shoot it because most of the time it serves me well. And I give it love so that it will continue to do so.
TLC
Yes,
goes a long way.
it needs love too.
Poor thing.
All right, so 6 over 2x plus 1 plus
42.
42x
Okay, thank you.
3x squared minus 4
What do you need?
plus 4 over x plus 7 times f of x. But we know what f of x is. What is f of x? The original problem. That terribly ugly thing that we didn't like until we changed it.
I'm gonna do a bunch of things. It's stuck in my head. I don't know why.
Oh my god.
Yes.
I used to sing that at 4-H camp
I
a million years ago in a land far, far away.
I watched it like once, honey. I don't remember.
Now they're both selected. There you go.
Yay. Wait. I do like the fact that you don't have to.
I know. See, I'm not even prompting them. I'm just saying it now.
No, he's been saying it all
I
day
forget
yesterday.
about viruses.
It's really not bad, right?
That's not bad.
Think of what it saved us. It saved us a lot of crap. That,
Would we
that's
have
terrible.
gotten the same, like,
Not the same
Format.
format.
It wouldn't have been the same format. I'd have to do a lot of algebra to check your answer, so please avoid that on your test.
Yeah, because if you were gonna, you would have to distribute that out all your test time though.
Would I be willing to get a problem wrong to see if you grade it? Cause I would mess up somewhere, inevitably I would mess up.
If in doubt, if I thought, I go, okay, that's a multiple choice question.
Ow.
Ew. And we transition. Okay?
That was definitely in transition.
Now,
It looks easier.
the first one that we did, we could have used the quotient rule, the product rules, and the chain rules, right? Yeah, who wants to? Okay, but we decided to use logarithms instead. The second one that we did, we could have used the product rule and chain rules, but who wants to do that? So we use logarithms instead.
Can we
Do we have a formula for a function to a function power?
No.
The answer is no. There is no formula for that thing in its current form. But is there something in math that allows us to just move an exponent somewhere? Logarithms let us do that, right? So if those were logarithms, we could bring that sign down front, and then we'd have something we could use. Get the idea? So not only does it get us out of ugly problems, but it gives us a tool for problems that we don't have a formula for. If you've got a function to a function power, there is no derivative formula for that. We need to rewrite it in something that we do have a derivative formula for. Are we clear on the why? Okay. It's a 50-50 shot. Ah. Who knows? I don't know. It's confused.
Could you, I'm not sure how it works with the y, but if you did a 1 base of x,
The logarithms, by definition, the base is a real positive number. So, I'm going to go ahead and rewrite that a little bit neater to show us what we've got. We've got that. But since it's a logarithm, I can bring the exponent down front, right? Not taking a derivative, I'm just using a property of logarithms.
I'm assuming that was for somebody.
Oh.
Wait, what? No.
So it's a use of problem where it's like, as sign, as just-
We have to try.
Product rule. Okay? Very, very common thing. When you have a function to a function power and you have to switch it to logarithms, you end up using the product rule. And it's a very, very common thing for calculus students to blow right past the product rule. You need to start recognizing the product rule. I got two things multiplied. I'm stuck with the product rule, but at least I have a rule that I can use, right? Before I didn't have a rule I could use. So, that's it's messing with me. I'm sorry. See, now that you've pointed it out, I can't look at anything else.
Wouldn't that be the generic formula as well, like function to power function is the power function multiplied by the
Yeah,
log
you could
of
turn it
x.
into you could call this an f of x and a g of x and turn it into, yeah. All right, so here we go. U prime over u. Because the left-hand side's not a product, it's just a natural log. So far, so good. Product rule. First times the derivative of the second. What's the derivative of the natural log of x? U prime over u, 1 over x. So there's first times derivative of the second plus second times derivative of the first. What's the derivative of sine? Cosine. And then we're in the exact same place we were before. Just clean it up and multiply by y.
Or the original problem.
The original
the
problem.
function itself.
So,
So something just clicked for me. I didn't-
yay!
I didn't realize that the entire time we've been finding the derivatives of equations
Uh-huh.
because I just thought that on the left side of it you just changed the notation, but you actually
We're
that's
taking the derivative, which
of-
is going to be
yeah.
extremely important
Yeah.
Monday. That's why I like, there's a couple things I could teach in a different order. I like doing this one right before Monday's lesson, because if that hasn't clicked before, it will click now. Okay, so y prime equals, this is sine of x over x, which is only 1 if we're doing a limit as x approaches 0, so don't mark it up. Plus, that stuff just kind of lines up, right? Times y, which was the original problem.
X is
So what I was wondering, you turn that on x over x.
That's only the limit as x approaches 0 of that.
So the reason you can't do what we have been doing with the addition and subtraction is the sine of x doesn't have the log.
Right.
Okay.
And it's not a product or a quotient. Well, it's not anything, it's just x to the sine of x. It's something to the power. So the only log rule we can use is to bring that exponent up.
I was talking like if
Yeah,
for
my brain
some
doesn't work
reason, if for some reason whatever, if sine of x where we brought it down had a log in front, we could do that. But,
Yeah, if there was a log out here, then we change it into a plus.
but
Good? So half the battle is knowing, do you have to introduce logarithms or do we choose to introduce logarithms?
We choose to.
We choose to. We could use the quotient rule and 2 chain rules, right?
Solve all that.
And, then I'll see you tomorrow and we'll see if you got it right.
tomorrow.
Because it'll take that long. Okay?
Actually, Monday.
Yeah, I know. That'd be the first problem. See you Monday. Okay, so do the first steps on your own. Rewrite it totally in terms of logarithms, but don't do a derivative yet. Okay? What do you mean?
Because the square root of 1 is 1, and the square root of x squared is x.
No, can't do that. Because it's plus. They've been outside on the side of the numbers.
Yes, I can. Sorry.
Is that what your first step looked like?
Yes.
Try the next step.
Which is. I suddenly can't remember that. Oh, yes. Yes.
When you're done with the next steps, look up, check and see if you got it right.
How did you get to
I did U prime over U for every piece.
that? Okay.
And then the constants just hang out in front.
I forgot.
So, Ms. Nichols, why does this number E come out so big? What's the purpose of it?
E pops up so much, is when they did circles, every time they did anything with a circle, the same number popped up over and over and over. So they gave it to me. The number E pops up a lot with like population studies. Like, cause most of population either growth or decay is exponential in some way. And that same number popped up over and over again. It's actually, there's a definition of it that has something to do with a limit. I used to know it one time. I don't know what it was about, but-
Paris.
Alright, how we feel about these?
Good.
Yeah, this gets you out of the chain rule.
Yes, it does.
So it's now your new best friend, right?
See, now I'm gonna pass the next test.
Of course you are. People's grades on that test are usually better. Because you can actually, on a lot of them, you can avoid a lot of misery by introducing logarithms. Okay, good? What time is it? Oh, we're almost done. Well, hey, there you go. I posted some practice problems on the blog already, and there's an old test already posted on the blog. Because they're awesome.
I don't like math though.
Oh,
You changed me.
I tried. My work here is done. I can retire now. Somebody will have to support me because I can't afford to, but.
That's gonna mean I don't think I didn't even.
Bless you.
Really?
Oh, Catherine.
Yes.
I forgot. So how did you bring it up? Oh, yeah.
Alrighty then.